Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Right now it is time to get into the science zone. I'm pleased to welcome here in the studio Dr. Dave, and tonight, as a first, Dr. Neil. Good evening to both of you.
Good evening.
Good evening.
Now, Dr. Dave, we know that the questions directed to you are going to be about why is it and how is it and one thing and another, all to do with sciences and physics and engineering. But Dr. Neil, what is it that you major in?
So I'm really a biologist, but I guess I specialise in viruses and how they kind of evade the immune system, but how the viruses get attacked by the immune system as well.
So those are our two contenders tonight. Straight off, actually, Dave, we've had an email in, and that is from Jeff in Southminster. He asked that he used to be a TV engineer, and during the learning of colour theory, they were told that the sky is actually green in colour and not blue. We were told that the human eye sees the sky as blue. True or not?
I'm not entirely sure about this one. Definitely your eye will have different sensitivities to different colours. So it's most sensitive to green light, and its sensitivity drops off quite quickly towards the blue. Definitely if you get sort of into the far bluey violets, you need an awful lot of energy coming in from them to actually see them. What he might be meaning is there's two different ways of measuring the intensity of light. One of them is how much energy is hitting you every second, and the other one is how many photons are hitting you every second. And this can cause all sorts of confusions with different detectors. But because blue light has more energy per photon, then possibly I think your eyes are more sensitive to a photon of blue light than they are to a photon of red light. So it could be that there are more photons of kind of turquoisey colour than there are of blue. And your eyes just kind of do all sorts of strange things. The way you perceive colour is incredibly complicated. Basically, the simple bit is you've got three different kind of cones in your eyes. One of them is sensitive to colours in the rainbow around reddish colours, another one in around greenish colours, another one around bluish colours. And then your just the relative amounts of signal in the reddish, greenish and bluish ones is how you see colour. Not everyone sees colour in the same way. Some people are colourblind, so they don't have a separate red cone and a green cone. They sort of have one which does both. I'm not sure if it's one which does both or whether they've just got the green cone.
I'm not sure.
Either.
Not sure.
Most people and that's red-green colour blindness. In fact, most mammals are red-green colour blind. So cats and dogs, they're not completely colour blind. They can see colour, but they've only got two different kinds of cones, so they won't be able to see distinguish reds and greens. And then there's all sorts of subtleties. And if the lighting in a room changes, your eyes adapt to it. Because if you're in a room lit by a normal old-fashioned light bulb, the light's actually very, very yellow. If you ever use an old digital camera, all the pictures come out very yellow. But your eyes kind of adapt to that and sort of redefine what they think of as white. And so all the colours look normal, even though the actual colour of light coming to your eye can change quite a lot. So I could quite believe that your visual processing system is doing some hideous trick, but I don't have any evidence specifically on that question, I'm afraid.
Now then, there's one here. Dr. Dave says, Mike in Peterborough, if NASA can put satellites around Earth's orbit, why not put them around the Moon's orbit?
You can make things orbit the Moon. However, for starters, you need to get a lot more energy to get there, because if you imagine if you're trying to escape the Earth, it's exactly like trying to climb a hill. So the further up you are, the more energy you need. So you could get a satellite to orbit the Moon for a bit. The problem with things orbiting the Moon is that there's a huge, great Earth sitting right next to you, and the Earth perturbs the orbit because of the gravity. Because basically, essentially, the tidal forces from the Earth will tend to mean that anything which is orbiting around the Moon its orbit will slowly change over time and become more and more distorted until eventually either it escapes the Moon and starts orbiting the Earth, or flies off into the rest of the solar system, or will end up crashing with the Moon. And I think the periods which things are stable for is actually only a few years. It's not tens of years or hundreds or thousands of years like orbiting the Earth. basically because the moon does perturb orbits of things orbiting around the Earth, but because it's so much lighter and the Earth is so much heavier, the perturbations are much, much smaller. So you can kind of overcome them by using little rockets to keep you in the right place. But you can make things orbit the moon, but they're not going to stay there very long.
Dr. Dave, is it safe to burn wood treated with preservatives?
I guess it depends what it's preserved with.
Well, yeah, you can preserve things with creosote or copper compounds and arsenic. And it probably depends, as you say, what it's got in it. So probably burning things with copper or arsenic in them isn't very good for you, especially if you're standing nearby, I imagine.
Arsenic is a classic poison, so you're
Absolutely.
not going to want to be breathing in an awful lot of that. And I guess even copper isn't very good for you.
No, you can poison yourself with copper. I mean, obviously, I think you need very low levels of it in your diet, but the levels are really, really low. I think it's a trace compound that you need.
Yeah, so, I mean, even creosote, which is, I think it's made from coal tar, which is when you boil up coal with water, you get gases given off, which used to be used for burning coal gas, and you get various horrible gunky stuff left over, which is really useful for the beginnings of the chemical industry. And I'm guessing it's got all sorts of poisons in it which kill all the bugs and stop the wood rotting. And I think essentially virtually anything which is going to kill the bugs and stop the wood rotting is not necessarily going to be very good for you. So if you are going to burn it, I'd make sure you burn it I wouldn't burn it in a stove anywhere the smoke's going to be in an enclosed area. You probably get away with burning it in the middle of nowhere when you're not going to be too close to the fire, but try not to breathe in too much smoke.
All right, well, Keith from Kettering wonders what kind of base the Germans used to fire the V2 off, and also what kind of bases are used nowadays to fire rockets and things off.
The V2 was the first ballistic missile, basically. The Germans developed it because their planes couldn't get through to UK and were getting shot down so often. It was basically a missile. It had a big rocket on the bottom of it. It had some form of fairly primitive guidance system, although when they were launching it from sort of beyond Holland, it could only just about hit London if it was lucky, burning oxygen and liquid oxygen and alcohol. Basically, it launched from a pad, fire for about 60 seconds, and the rest of its trajectory, it would just fly off from the velocity it had gained in those 60 seconds, and just come down incredibly fast, and there's just nothing you can do about it. How were they launching them? They started off launching them from basically sort of concrete pads. They'd have a big underground bunker with rockets in them, and then sort of trundle them out, lift them up on a kind of raising gantry, and launch them from the concrete pad. This was fine until the RAF identified what these pads were and started bombing them very, very heavily. So after that, they built sort of trailers, and they could move the rockets around on trailers, and they'd launch them from the middle of forests and keep moving the launch pads, so it was much harder to bomb. In which case, I think they could set them up in a sort of couple of hours in a sort of clearing in a forest and just launch them straight off. Modern rockets... It depends on the rocket. Most rockets are just big concrete pads. The American rockets tend to be built vertically, so you have a rocket and then you put on there tend to be multiple stages. You have a bottom stage, now another stage on top, another stage on top, so it's sitting vertically. Then they'll have some kind of crawler or something to move them out to the pad and then launch them vertically. Russian rockets, they build them horizontally and then kind of have a big sort of hydraulic ram to lift them up vertically, then launch them upwards. Some of the more exotic ones, there's a company which Boeing owns called Sea Launch, where basically, because if you can launch a rocket from the equator, it's already moving at 600-700 miles an hour, but probably more than that from the equator, because it's already moving because the Earth is spinning, so that's energy you don't have to put into it, which means you can put more mass on the end of the rocket. So what they're doing is they're launching from the equator on an old oil drilling platform. So they have a big ship with a rocket in it, then the ship docks with the platform, they move the rocket onto the platform, the rocket gets put upright, and it'll launch off from that. There's some other ones whereby, for small rockets, for very small payloads, you can sling them under basically a big bomber, a big plane, fly up as high as the plane will go, and then launch the rocket, in which case the rocket's got the extra oomph of starting off at 40 or 50 kilometres upwards. It's less atmosphere to get through, so it's a lot easier.
Tony is on the phone, so let's say hello to him. Good evening.
Hello, Sue.
Hi, good evening, Tony. You're through to Dr. Dave and also to Dr. Neil.
Right, Sue. Good evening, sir. It's a lot of lightning going on at the moment, not at this very moment, but, this
I noticed I got very wet.
I'm sure,
thanks to
I just wondered if you explain, why is it sometimes fault lightning when it comes to Earth, and sometimes sheet lightning.
Okay, basically lightning occurs because in big thunderstorms the clouds tend to charge up. You get lots of air rushing past raindrops, and this tends to sort of rub past them and start to charge them up. There's also the complex effects. I think it's quite a subtle system, and I certainly don't understand it fully, but definitely get very high charges in the clouds. Then this charge builds up so much and it wants to go somewhere. And if this charge can get down to Earth, you get a huge current flowing down, essentially what is a massive spark. So at some point, the air splits up. So some of the electrons will fall off some air molecules, and then they'll start flying away from the cloud or towards the cloud. They build up lots of speed. They bash into another air molecule, which knocks more electrons off, which will fly up and knock more electrons off and more electrons, till eventually you get a whole line of air with lots of electrons moving up and down, and then that conducts electricity really well, at which point the huge amount of charge in the cloud can suddenly jump down through this conducting path down to Earth. The original creation of this line tends to happen in sort of jumps, so you get all these sort of like forks, and it tends not to be very straight, so it'll charge off in one direction, then it will decide actually it's better to go off in another direction, another direction, another direction. You actually get lots of little leaders which sort of peter out, and you just get one very strong one which gets a really big lightning strike back down again, and that's what you actually see as lightning. Then the air gets really hot and expands, and then it shakes the air. You get this basic explosion, long thin explosion of air expanding very rapidly because it gets up to thousands and thousands of degrees centigrade, which means it's very hot, so it expands, and then that causes vibrations, which you hear as thunder. Now, so basically all lightning is originally fork lightning. It can go all the way down to Earth, or it can actually go between different clouds. But if you get a lightning strike inside a cloud, so you can't see the fork bit, the cloud's going to light up, and it looks like a sheet because it's actually like the fork lightning inside the cloud, lighting it up, so it looks like a sheet, and that's what sheet lightning is.
Oh, lovely! I got struck by lightning once, actually.
How did you manage that?
Well, I was a wireless operator during the war. What do they call it? The direction finding, I just think it hit the air and it made me jump, I tell you.
I bet it did. Thank you very much, Tony.
That's all right.
Thank
Love
you.
to talk to you again.
And you too. Bye-bye.
Bye.
Now, Ian in Colchester, following on from that, wonders why lightning happens in a split second but thunder lasts so long, and why aren't lightning conductors insulated at all?
Now, lightning's so quick because electricity flows very, very fast. It flows at almost the speed of light, so the charges can redistribute themselves in a fraction of a second. Even though it's travelling several kilometres, that'll happen incredibly quickly. If you're very, very close to the lightning bolt, the thunder sounds like it's very, very quick as well. I don't know if you heard them going off above your head. It's incredibly loud and very, very sharp and very, very quick. The reason why it tends to get spread out the further away you get is basically reflections. Because the further away you go, the sound can travel straight towards you. It can kind of bounce off hills. It can actually bounce off clouds, and it can actually get sort of bent round by the atmosphere and come back down again. And all of these different paths, these different routes it can take to get to you, take different amounts of time. So the stuff coming in a straight line towards you, a bit of it will get come in a straight line towards you, which will get there quite quickly. And other bits will take a bit longer going around the sides. And so instead of having a really sharp crack, it gets spread out over a big sort of rumbling, thundery. The reason why thunder tends to rumble and get louder and quieter is you get different echoes and different refractions as it gets bent up by the atmosphere itself. And so it will get louder and quieter as you hear all the different, essentially, echoes. And so, rather than a sharp crack, you get this big, long rumble.
What about lightning conductors, though? Are they insulated? Why aren't they insulated?
Why don't they insulate? Probably because it's hardly worth it.
Well, I think they don't actually work by conducting lightning, do they? Don't they work by redistributing ground level charge to the top of tall buildings, I think? Yeah,
there is one thing whereby they can, but the reason why they're sharp is that they'll tend to release, you get electrons, basically the charge gets released from the lightning conductor, and that actually sort of forms a big cloud around the building, which makes it less likely to get hit. But if it does get hit, the lightning conductor is a bit which will get hit. And the reason, you could do the dissipation thing with a very, very thin wire, and that would work fine as long as it had a sharp tip.
Yep.
But the reason why they're always huge and made out of copper is because the lightning might hit there, even though they tend to discourage it. And when it does hit, you want to conduct it down the nice big heavy piece of copper, which isn't going to get very hot, isn't going to explode, rather than the house, which is. And so what you do, and I think basically they don't bother insulating them because the voltages in lightning are incredibly high. And so if it's going to any sensible amount of insulation, lightning could jump through if you want to. And the other thing is, if the idea of them is to be very, very low resistance, so they're attached to the ground very, very well. So probably even if lightning hits them, probably the voltage doesn't get that high because it will just flow all the way through, because it would always rather go through the lightning conductor than through anything else. So odds are you're not going to get any very big currents flowing out of the lightning conductor.
Hello to Lefty from Peterborough. If black holes exist, do you know any of the theories about white holes existing?
I have heard of white holes. Various people have kind of hypothesised that everything going into a black hole might not just... Basically, a black hole is when you get so much mass in a very small place that it bends space and time so much that even light can't escape. And so if everything which falls into a black hole, as far as we know, couldn't possibly... If light can't get out of something which has no mass at all, then anything with mass is going to get attracted to it far more and is never, ever going to escape. And now various people have hypothesised that what a black hole might be is a kind of a hole into somewhere else, sort of a jump in space. And so somewhere else, for every black hole, there's something else which they call a white hole, which is spewing stuff out again. There's definitely been no evidence for one being found. Various people have hypothesised it, and I think normally it requires some exotic types of matter, which we haven't found either. So I'm afraid I don't know any more than roughly what they are.
Hello to Gus, who says, apparently Bluetooth mobiles and other gadgets emit radio signals that, with special scanners, can be used to track targets' identity without their knowledge or permission. How does this work? Could this turn into a future Big Brother surveillance system?
I don't know about a future Big Brother surveillance system. It's certainly being used at the moment with mobile phones. A lot of these things, definitely mobile phones, every now and then, they basically, the way they work is they'll shout out the network and say, I'm number 5689, whatever their identification number is, they'll shout that out and say, I'm that. I'm here, I'm waiting to talk. If you want to talk to me, I'm here. And so the nearest base station knows that it's near you. So definitely there have been cases, the Israelis and I think the Americans as well have got missiles which can home in on a phone call. So if someone's talking on their phone, then the missile can get the signal from that phone and it will only pick up the signal from that phone because of this identification number on it. And then it will home in and hit the phone. The Israelis have used it to assassinate quite a few members of Hezbollah and such like. Bluetooth, I could imagine, is doing the same thing. It probably is always sending out its own ID numbers in case anything else wants to talk to it. So if your printer wants to talk to your phone and your phone comes near the printer, then they can start talking. Bluetooth signals are a lot shorter range. So they definitely only work over at the most 10 metres. So even with really good pickup systems, you're probably not going to pick it up much more than a couple of 100 metres. So I think they'd be less useful. But definitely mobile phones. You can pretty much track a mobile phone in this country to within definitely a few hundred metres. In the States recently, they've made a law whereby you have to put GPS in mobile phones so that they can track you to within less than a metre all the time. It is, the whole thing is very scary.
All right, let's go to John from Peterborough. He says, since natural gas is running out, can we go back to coal gas?
There's no fundamental reason why you couldn't go back to coal gas. Basically, you get some coal, you heat it up, and then you react it with water, and then you get a mixture of carbon dioxide, a bit of carbon dioxide, quite a lot of carbon monoxide, which is quite poisonous, which is why people could kill themselves by putting their head in a gas oven. It basically locks onto the haemoglobin in your blood and stops it being able to carry oxygen and some hydrogen as well. And so we could make coal gas. I think it would be unpopular because it's far more dangerous than natural gas, as it's actually poisonous. And you'd have to, when we converted to natural gas, everyone had to change all the jets in all their cookers, so they'd have to go back again. The other problem is it's going to create a lot more carbon for every unit of heat than natural gas does, so it's going to make a lot more carbon dioxide, which is even worse for the environment than natural gas.
Rex in Shenfield asks about poisonous yellow flowers by the side of the motorway called ragwort, but what makes them poisonous?
So the poison in ragwort is actually something they make to stop them being attacked by animals, effectively. If you like, it's a natural pesticide, and they're called alkaloids. And you might ask why you can go out and rip them up and not get kind of rashes on your hands or be poisoned. And it actually needs you to eat them, and your body breaks these kind of molecules down into poisons. And it's actually only the breakdown products that are poisonous, and it builds up in your liver, and it's the liver damage that kills you in the end.
Now we know. Thank you, Dr. Neil.
Yeah, I think it can be quite a big problem with animals eating them.
Yes, it is.
Definitely, if they eat a lot of them. Apparently according to this website, if they're not eating too much, then it definitely won't kill them. It might not be too bad for them, but definitely if they eat a lot of it, maybe it tastes nice, and they eat a lot of it, and then they're in trouble.
Now, Joe from Great Yarmouth asks, how likely is it that a radio mast to get hit by lightning, and what would happen if it did? Are there backups?
I would have thought that it's very likely for a radio mast to get hit by lightning. It's a big metal object high up. It's going to be a lovely conductor of electricity down to the ground. So the easiest route for the lightning is going to be through the radio mast. I don't know specifics. I expect there are people who work here who do, but I'm sure that they're designed very carefully to try and reduce the number of. There'll be a fairly big lightning conductor on the top of them, or to reduce the number of times they get hit, and so that if they do get hit, that it doesn't damage them too much. I don't know whether they put sort of some kind of crazy fuse or one way of protecting things by lightning. Against lightning, which you can use in your home, quite a lot of the surge protection plugs do this, is you have a piece of material, you have a piece of material which has a high resistance unless the voltage gets above sort of 400 volts. So if the normal mains is working, then the voltage is much too low for that to happen, and it's high resistance, and so it doesn't affect the operation of the device or the power cable. But if the voltage gets very high, like when it gets hit by lightning, its resistance drops to almost nothing, at which point all the current flows through this device away down to Earth safely and protects your expensive piece of electronic equipment. So I'm absolutely sure that they've got lots and lots of this kind of device on the radio masts, protecting the complex and expensive pieces of equipment sending out the radio.
Carl on the A14 has called in to ask, what's the difference, Dr. Neil, and we all want to know this, between the cold and the flu virus?
That's a good question. So the flu virus is actually something very specific. It's a specific type of virus, if you like. The cold virus is a much more generic term. So colds can be caused by any number of viruses. There's at least 3 or 4 totally different virus families that can cause colds. So when people talk about the cold virus, they're actually being very unspecific. Whereas when someone says they've got flu, often they haven't. They've actually got a cold virus. But when people say they've got flu, that's actually a very specific virus. So it's the difference between a generic kind of virus symptom and an actual virus family.
Viruses can be very nasty as well, because very often you'll go to the doctor and they'll say, oh, you've got a virus.
And there's nothing they can do to treat it.
No, it's really weird. Must be very interesting, your work. How far advanced are we in the land of viruses?
Well, it depends on the virus you're looking at. I mean, things like the colds or flu, I guess you generally just treat the symptoms, whereas viruses like HIV and things which cause big problems worldwide, kind of treatments are a lot further along for those. So they've got specific drugs now, and maybe eventually there'll be a specific anti-cold drug.
Let's hope so. One here, actually, from Tarquin, sent an email and said, maybe your scientist has a view on this. What happens when science, the medical profession, keeps everyone alive forever? Road safety stops cars from crashing, planes stop flying and crashing, i.e., why do we keep looking for ways to perpetuate life forever? Will I go outside and join the queue, to join the queue, to join the queue, etc.? What's the point? Is there a point? What is wrong with the average 70 years and 10 with a few others falling off on the way?
Well, I guess life will never be totally risk-free. I mean, there'll always be lightning coming down, or maybe we'll cure that one day as well. But I don't know, I think curing diseases and things has got to be a good thing. Living forever, I'm not so sure about that. I guess you'll still get old, but who knows, maybe ageing will stop as well.
I think fundamentally it's because people have a deep need to survive, because we've evolved. Basically, the people who haven't had a deep desire to survive didn't breed. They felt jumped off a cliff or something because they thought it'd be fun, and then they didn't have any children. So all of the creatures which have survived the last 3-4 billion years are the ones who have a deep desire to survive, and so we don't want to die. And it's not a thing about science; it's a thing about people. We don't want to die. It's the way we've evolved.
Dr. Dave and Dr. Neil, thank you very, very much indeed, and we look forward to seeing you in the not-too-distant near future. Be safe. Thank you, Dr. Neil, Dr. Dave. That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.